Imagine you're an analyst, handed the full 3-year order history for your company. That is 50 million rows of data, sitting inside a 15 gigabyte file. You load it into your standard Python script and hit run. Almost immediately, your standard laptop completely freezes. Your cooling fan starts screaming, and then the Python kernel crashes. Traditional data tools attempt to load every single row of that file into your computer's short-term memory at the exact same time. The total size of the file is not the real issue here. Your hard drive has plenty of space. The bottleneck is a software architecture that demands the entire 15 gigabyte dataset live simultaneously inside your active RAM. To understand why the machine choked, we need to look at data in terms of scale. On the low end, you have small data, anything under a single gigabyte. Standard libraries handle this effortlessly because the entire dataset easily fits into memory. On the extreme opposite end is big data. These multi-terabyte datasets require distributed computing clusters to chop up the workload. But sitting between those extremes is a vacuum. This 1 to 50 gigabyte range is what we call medium data. Applying small data tools to this middle zone leads to the exact crash we just saw. Your laptop tries to swallow a 15 gigabyte file whole and suffocates. Moving to a big data solution means renting expensive cloud clusters and configuring complex networking layers just to process a file that already fits on your physical hard drive. What you actually need is a targeted software architecture built specifically to bridge this gap. Success in the medium data zone depends on how the software retrieves and sequences information. Enter tools like Polars, a high-performance Python library specifically designed for out-of-core processing. Out-of-core processing never loads the whole file at once. Instead, it streams data directly from your hard drive, feeding sequential, bite-sized chunks into your memory. Traditional tools use eager execution, trying to ingest every piece instantly, clogging the system. Polars avoids this by utilizing a concept known as lazy evaluation. A lazy processor delays actual computation to analyze your final goal first. It builds an optimized query plan. If you only need sales from 3 zip codes, it maps a precise route to filter those exact rows, entirely bypassing the rest of the file. Once the plan is complete, it executes. The system extracts only the precise information required, pulling it into your active memory. Strategic query planning allows a standard laptop to process datasets that would otherwise be impossible to handle locally. If you are an analyst who prefers writing SQL, you've likely faced a similar wall. Running massive analytical queries usually forces you to upload your files to an external database server. You can apply this exact same out-of-core architecture locally using DuckDB, which functions as an embedded analytical database. An embedded database doesn't require a separate server. It operates entirely inside your script, running SQL queries directly on top of the raw CSV or Parquet files sitting on your local hard drive. Eliminating network transfers and cloud servers allows complex analytical queries to run privately and immediately on your own hardware. Let's return to that 15 gigabyte order history from the beginning. By swapping your standard data tools for Polars or DuckDB, you hit run, and the exact same laptop processes and groups all 50 million rows in under 2 minutes. No crashes, no screaming fans. Often, spinning up heavy big data infrastructure is an expensive overreaction to what is fundamentally a medium data problem. Mastering software architecture allows a single workstation to manage the medium-scale workloads that previously demanded a server farm.